Hi everybody, and welcome to lesson 7 of the measurement unit. Today we're going to be looking at surface area and volume of prisms and cylinders. Okay, so again, you might have come across this before, surface area and volume. Okay, if I were to define those two things, volume would be the amount of, let's say I had a box, okay, and it would be the amount of water that would fit in that box. That would be the volume, while the surface area would be the area on the outside, or in other words, if I wanted to paint this box, how much paint would I need to get to paint the outside? That would be the surface area. Okay, specifically, we're going to be looking at right prisms, and the key thing with right prisms is they have the sides of the prism is rectangles. Okay, there's all sorts of prisms you can get. They're just three-dimensional objects. But right prisms are prisms with whose sides are rectangles. Okay, so that's important. And again, you can read some of this right here for some more specific definitions. And again, you've come across this before. We get a triangular prism, a rectangular prism, and then we have the common cube. Okay, so now again we have the volume and the surface area. The thing about the volume is that the equation for the volume of any prism is just the area of the base times the height. Okay, and then for the surface area, all you do is just get the area of each of the sides and add them up together. Okay, so let's just get into some formulas here. We have the perimeter, which is obviously the distance around the shape. Okay, so again, if you forgot the equations for the circle, that would be the perimeter of the circle, also known as the circumference, would be pi times the diameter, or 2 times r times pi. Okay, now two-dimensional shapes, we have some common ones here. The rectangle, base times the height. Again, you can go through all of these. You won't be required to memorize all of these. You will be given a formula sheet with some of the common ones, but obviously you should know, some at least these 4 shapes over here. Okay. Now let's see if we can do some calculations here. So we have a right triangular prism here. Determine the area of the base. Okay. Well, the area of the base would be obviously down here. That would be the area of the base, which is just a triangle. So what is the area of the base? Well, first of all, what shape is the base? Well, it's a triangular prism, so it's a triangle. So the base of the prism, so we have the area of that triangle down there. I'll put a little triangle there, is just base times the height. In this case, the base would be 10. The height might be a little bit harder to get here. The height would be, again, remember how we get the height. We draw a straight vertical line down from the tip of the triangle. Now we might have to do some Pythagoras here to get this height here. We're going to look at just this little triangle in the red to get that the height. So what is that? We're looking at, we'll just use Pythagoras, so it would be 13 squared minus 5 squared equals, and we can label that the height equals the height squared. Now how did I get 5? Well, that would be half of 10 over here. Okay, so 13 squared is 169 minus 25 equals the height squared. That is 144, and the square root of that is 12. So our height of this triangle is 12. So 10 times 12 would be 120. So the area of the base is 100, and this is what, centimeters? So 120 centimeters squared. Okay, the volume, okay, would just be the base, the area of the base times the height. Oh, look at that! I made a mistake up here. You have to divide everything by 2 in order to get the area of a triangle. I was doing the area of the square there, so it's 60 centimeters squared. Okay, I'm sure most of you have caught that one. Okay, here we go. The volume of this, again, so it's the area of the base, and maybe you can put a little area little subscript there, area of the base times the height. So we have 60 times the height, which is 6, and that would be 360. Now that would be centimeters cubed, okay, because we're looking at 3 dimensions now, base times the height. Okay, determine the surface area. The surface area, you know, this can be a little tricky here because we have so many different shapes, but basically we have 2 of these triangles, the top and the bottom, the base and the kind of the top of that, so that if each one of it is 60, so we have we can do this, we can do a little diagram, might help you out here. So we have 2 triangles, a little 2 times the triangle, okay, and then we have 1 rectangle. I'll do that in green here. So we have 1 times this rectangle here, and then 2 times this rectangle over here. I'll do that one in black. This rectangle over here, where there's 1 on this side, and obviously there's 1 on the other side, and hopefully you don't miss that one. So here we go. I'll do that one in black. That one's a little bit bigger. Okay, so those are all the sides that we have here. And I'm just going to do just add them all together. So again, we have the triangle, which I already did. So each one is 60. So it's going to be 2 times 60 for a total of 120 centimeters squared. This triangle here, a rectangle rather, this one in green here, well, this is going to be 6. The height is the same all around. It's just going to be base times the height, which is 6 times 10, which again is 60 centimeters squared. And then the bigger triangle is base times the height as well, except the base is 13 times the height of 6, and we get 78 centimeters squared. Okay, once we add all that together, what is 180? 258. So the final number is 258 centimeters squared. All right, moving on. Okay, here is kind of the most important section here. Just some of these conversions between cubic measurements and liquid measurements. So, for example, if you have basically any prism or any solid shape like a box or whatever it is, that volume would be measured in well, depending again what units you're using, but it could be centimeters cubed, meters cubed, because that solid will have 3 dimensions. So it's going to be you know, cubic units here. Now, when we start getting into liquid, how much liquid can fit into these solids, we're looking at liters, you know, gallons and imperial units and that sort of thing. So we need to know the conversion between the two. Okay, so how much of a certain solid, in other words, how many liters can fit into my triangle over here, into my 360 centimeters cubed. Okay, I need to know how big that is. Okay, and here's some of the most common ones. Okay, so this is the one you're going to see quite a bit. 1 centimeter cubed, and by the way, 1 centimeter cubed is just a centimeter like this, and then we have we're going to have just basically, that is a terrible drawing. Let me do that one again. Okay, so I have a centimeter cubed. That's a little better, like this, and you know, how much liquid can fit into that centimeter cubed? Well, only 1 millimeter of liquid can fit into a centimeter cubed. And this is not a surprise that, you know, these things match up 1 to 1 like this. And therefore, you know, if I was to look at 100 milliliters would equal a liter. Therefore, if I had 1,000 centimeters cubed, 1,000 centimeters cubed, that would be a liter. Okay, we have here gallons. Okay, gallons, again, gallons to liters. You're familiar with a gallon. Okay, maybe a typical milk jug is a gallon, and you know, it's 3.7854. But you know, if you're talking to if you need to do a quick calculation, maybe you go down to the States and you want to get the price of the gas, because their gas is in in gallons, and you want to compare that to our gas prices, which are in liters, you might just want to do a quick calculation of multiplying by 4, which usually does the trick, gives you a rough estimate too. Okay, the imperial gallon is different. It's more than 4 liters. It's actually 4.5 liters. Okay, and then a gallon, again, this is US gallon, has 8 pints. Okay, and a pint is about half a liter, I believe, for 500 milliliters. Anyway, okay, let's do some examples with that right now. Okay, I'm going to skip this example. It's a little bit wordy. You guys can try that one at home. I will cover some of the same ideas in the next couple of questions here. Okay, moving on to cylinders. Okay, a right cylinder. Okay, again, the right cylinder has has a circle as its base, has a certain height, and the general rules are still the same. Okay, for the volume, it would be the area of the base times the height, and for the surface area, it would just be adding up all the different shapes. Now here's what when you cut up the cylinder, you basically get a rectangle, the rectangle which corresponds to the middle part here in red. Okay, and then you have the 2 circles on the outsides, which I'll do in green here. So those are the green. Okay, and the area of the circle is pi r squared. Okay, now so here's the surface area. So again, if I were just to add up these here, that would be but again, you just got to be careful here, because the area of the rectangle is length times width. Well, this would be the width and this would be length. However, that length is really the circumference of the circle when it's unwrapped and made to look like a rectangle. So that length, we have to convert it into circumference, and circumference, remember, is 2 pi r. So really the length is 2 pi r, and then the width, well, that would just be the height. That would just be the height of the cylinder. So this is another way of looking at this rectangle in terms of the radius of the circle and the height of the cylinder. So if we were to now add those up, it would be pi r squared, and there's 2 pi r squares because that's the circle part, and then 2 pi r height, which is the rectangular part. All right. And then the volume of the cylinder is would be terrible cylinder. Okay, the volume would be, again, the area of the base, which is pi r squared times the height. All right. There it is, pi r squared times the height. Okay, let's do a couple of these harder questions. You can try this one here, and I'm going to jump on to a few of these down here. All right. So solving for a measurement given the volume. Okay, a commercial garbage bin in the shape of a cube has a volume of 60.24 meters cubed. Determine the dimensions of the garbage bin. So the cube volume of a cube is well, it's side times side times side, so side cubed. Well, that's just going to be the cube root of 60.24 to get the side. So the cube root of 60.24 will give us the dimensions of the garbage can. All right, let's try this. Some other ones here. The box of Toblerone chocolate bar is in the shape of a triangular prism. The triangular faces have a base of, let me go ahead and draw the little Toblerone here. All right, there's a Toblerone there. Okay, the triangular faces have a base of 3.7. That would be there, 3.7, and a height of 3.2. So 3.2. If the space in the empty box is of this volume, determine the length of the box to the nearest tenth of a centimeter. So we're looking for the length of the. We're looking for from there to there the length of the box. So we have the volume. The volume is base times the area of the base times the height. Well, the area of the base would be 3.7 times 3.2, and then don't forget to divide it by 2. That's the area of the base times the height, which we don't get. That's actually what we're looking for. The length of the box would be the height, except now it's, you got to kind of visualize this, you know, this thing is turned on its side. Okay, so the volume is 123.7. I should get my calculator out here. So 3.7 times 3.2 divided by 2 is 5.92. So 5.92 times the height. Divide both sides by 5.92, and the height equals, so 123.7 divided by 5.92 gives me 20.9, nearest tenth, 20.9, and the units would be centimeters, so centimeters. Okay, let's do this last one. Poster company has decided that all of its posters will be shipped in cylindrical containers with a height of 17 inches and a circumference of 2 inches. A curved surface area of the container will be wrapped with a paper label containing the company's logo. Calculate to the nearest inch the curved surface area wrapping of the container. Okay, so we have a well, that's probably going to look a little different than that, but there's my cylinder. Okay, has a height of 17 inches. That's that height there, and a circumference of 2 inches. Okay, so the curved surface area container. Okay, so we're looking for the nearest. We're looking for the surface area of the wrapping of the container. It looks like just a curved surface will be wrapped. So all I need really is the area of that rectangle, which once unwrapped, okay, it's going to be 17 here, and then the circumference, this is going to be 2 inches. My diagram really should have been like this. Obviously, it's for a poster, so this is 17, and the circumference is 2. So when you unwrap that, you get something like, maybe like that, a rectangle that looks like this with 2 inches and 17 inches here. So the area is 2 times 17, 34. 34 inches squared is the curved surface area. Okay, guys, thanks for watching, and we'll see you next time.